In this video, we're going to discuss the puberty of a female. So one of the things I like to do is start out with the estrous cycle, so make sure you start really paying attention to the hormone profiles of a mature cycling female. Then we'll also kind of backtrack to trying to identify what's the switch between being prepubertal, so non-cycling, or in some cases we can define that as being anestrus, to then becoming a cycling female. And this here, we're going to really focus on the prepubertal female, and then in the next few chapters we'll talk about kind of the anestrus female from a mature standpoint. So to understand where we're headed, we have to take a look at the female's estrous cycle. So to understand the difference between a prepubertal female and a mature cycling female, we really have to start with the estrous cycle. We're going to spend much more time in chapters 7 through 9 discussing the estrous cycle, but I wanted to give you a quick review. So a couple of things just to refresh your memory. Hopefully this is starting to look familiar. We've got estradiol. Here's a follicular wave. Here's the recruitment of a second follicular wave, but this is estradiol. Then we have progesterone. We could also add oxytocin to that, but that's progesterone. And when we look at the estrous cycle, we essentially have 4 stages. 2 represent the follicular phase and 2 represent the luteal phase. So if I go over here and I'm going to highlight medestrus and diestrus, so in our yellow, they represent the luteal phase. So I chose yellow because think of there's going to be a corpus luteum. Okay, that's the structure of key interest. And so during this diestrus stage, we actually have a mature CL. And remember, medestrus and diestrus, the luteal phase represents 80% of the estrous cycle. Okay? One of the things also to get used to is thinking about the structures that are available or on the ovary during these different stages of the estrous cycle. So if you think back, during medestrus, we have a corpus hemorrhagicum, so that's the transition from a follicle to a corpus luteum. And remember, the corpus luteum is what produces progesterone. And then if we look at the other 2 stages, okay, so we've got estrus and we have proestrus. Those 2 represent the follicular phase, okay. Let me get this kind of cleared up for you. Those 2 represent the follicular phase and represent roughly 20% of the cycle. And in this particular case, during estrus, if we want to think about structures, okay, during estrus, we're going to have a follicle, right, on the ovary. Okay, so we have a follicle during estrus. Same with proestrus, but proestrus, remember, this is luteolysis here. Okay, so at this point, that's luteolysis here. This right here is luteolysis. That's going to be the regression of the CL. So during proestrus, we actually have the old CL that's becoming a corpus albicans, okay, but we also have a new follicle because realize we're going into a new estrus stage over here, so we also have a follicle on the ovary. So get used to thinking about what structures are actually on the ovary during the different stages of the estrus cycle. Okay, so 4 stages of the estrus cycle. Estrus and proestrus represent the follicular phase. Medestrus and diestrus represent the luteal phase. So that's where we're headed. That is a mature cycling female. Okay, so now that you understand where we're headed relative to a cycling female, let's start looking at how did researchers figure out what were some of the factors, or what are the factors that seem to be related to when puberty actually occurs. So in trying to figure out the factors that influence puberty, researchers realized that you could induce puberty hormonally in a 2-month-old and have her reproductive tract ready to support a pregnancy. Although in reality, yeah, we might be able to have a reproductive tract ready to support pregnancy, but really think about in a heifer, she should reach puberty around 10 to 12 months. So she won't be a mature size to actually carry a pregnancy to term. But we use this as a model to determine what factors influence puberty. What is the switch, essentially? So one of the things I want you to think about, we're going to go through this, how did they determine what controls puberty using three key components. And if you look at them, that's our HPG. So here we've got So here we have GnRH, FSH and LH, and E2, and we're going to give that to the female and see what happens. But remember our HPG. Okay, so just really quick, just to, if you want to draw, remember we've got the hypothalamus. I'm just going to put an H there. Okay, it produces GnRH. That's going to have an effect on our anterior pituitary, right? And that's going to release FSH, LH, and then that's going to affect our ovary. Okay, so here's our ovary. I'll just put an O for ovary. Okay, so what we're looking at is trying to determine what is that switch in puberty. And so as we look at this, so what the researchers did is they took a 2-month-old calf and they gave a shot of GnRH. So what they're doing essentially is they are simulating the GnRH surge, right, or GnRH release here. So that's number one. So I want you to think of, okay, we gave GnRH. It should impact, if this were a mature female, what should it do? Okay, if we have a GnRH surge in a mature female, it should cause that female to release FSH, right, and LH if the anterior pituitary is mature enough to respond. In other words, if the anterior pituitary is working, if we give a shot of GnRH, it should end up causing a release of FSH and LH. So what was the result? It's actually what we would expect in a mature female. So the result, we got an increase in FSH and LH. So when we gave a shot of GnRH, it caused the anterior pituitary to release FSH, LH. So that is what we would expect. Okay, so I'm going to put over here, in terms of a mature female, we got what we expected. Okay, that GnRH caused the release of FSH and LH. So one of the things you can carry away from this is that the anterior pituitary is operational. It's functional at this point. Okay, so another result of this is now we know the anterior pituitary is functional. And I'm just going to write function. Okay, so we know the anterior pituitary is functional. Now, what happens if we give FSH-LH? What's the expectation? If we give FSH-LH, we're going to expect some follicular growth that is going to cause the release of estradiol. Right? So if the ovary is mature, okay, and can respond to FSH-LH, we should expect E2. What was the result? We actually got follicular growth when we gave FSH and LH to this female, and we got E2 production. So in this particular case, okay, so we're going to put number 2 here. In this particular case, we got exactly what we would expect in a mature female. Okay, so in this first case, we gave GnRH that caused FSH and LH to be released. In number 2, we gave an injection of FSH-LH to this 2-month-old. We end up getting follicular growth and estradiol production. So that's what we'd expect from a female. Now, what happens if we take it the next step and we actually give the estradiol to the female, and what happens? Okay, so in a mature female, we would expect, if we were to give threshold levels of estradiol, that should cause a GnRH surge. So what do you think happened? Okay, we did not get what we expected. Okay, so in this particular case, even though we had threshold levels of E2, we got no GnRH surge. And that was a key finding, because what that told us was that in this particular case, when we got to this point here, something wasn't working the way it was supposed to in a mature female. So in this particular case, it began to reason that the hypothalamus wasn't responding to threshold levels of E2. So while the anterior pituitary is mature and fully functional, and the ovary is functional in terms of producing follicular growth, producing E2, the hypothalamus, for whatever reason, is not responding to estradiol. So that leads us to discussing more about, okay, well, it appears that the switch itself, okay, is whatever influences GnRH. And because you'll see this later, Kisspeptin does play a role in this, okay? But think of this in terms of when they identified what was the switch from becoming prepubertal to becoming pubertal. Remember, it is anything that's essentially affecting GnRH secretion. So in this particular case, as we look at what happened here in step 3, we did not get the effect that we thought that would occur here. We got no GnRH surge. Okay, so here's the thinking. We know that there's estradiol, okay, but it's not producing its expected effect. So it was deduced that there must be negative feedback sensitivity, and really we're talking about the tonic center here, to estradiol. Okay, the hypothalamus is not responding to high levels of E2. We're not getting follicular growth. So it's not causing the cascade of GnRH, FSH, and LH. So we did not, we don't get the typical response. So what appears is that there's not enough gonadal estradiol to stimulate the surge center. Okay, so obviously there's low levels of estradiol. There's a negative feedback sensitivity in the tonic center, so it's not allowing for regular levels of GnRH or expected levels of GnRH and FSH, LH. So that's that special note at the bottom there, that low frequency GnRH pulses aren't enough to stimulate the needed FSH, LH. And if you don't have that, we're going to get very minimal follicular genesis in the female, so we're going to get very little follicular growth. And then from the male standpoint, we don't get spermatogenesis. Okay? So in the prepubertal female, we know there's a negative feedback. Okay? The tonic center of the hypothalamus has a negative feedback sensitivity to estradiol. So whatever estradiol is there is negatively impacting the hypothalamus, thus decreasing GnRH release. And really, if you think about it, what it's doing is essentially not allowing for GnRH to be frequent nor at a very high pulse rate. So what's the switch? In this particular case, up until puberty, E2 is having a negative feedback loop essentially on the tonic center of the hypothalamus. So the more E2 there is, right, the more negative impact there's going to be. So what's the switch? Well, if we look at it, it's going to be the fact that negative sensitivity decreases. So we actually get this a less negative effect, and when we do that by reducing that negative impact, we get more GnRH, right? If we have more GnRH, we're going to have more FSH and LH, and then we're going to end up getting follicular growth, okay, follicular genesis, and in the male we get spermatogenesis. So prepubertal estradiol has a negative feedback or negative impact on the tonic center of the hypothalamus, and that reduces GnRH, thus FSH and LH and follicular growth and so forth. But the switch is this, that as that negative sensitivity decreases, we start accumulating higher amounts of GnRH. Okay, so we get a higher pulse and higher pulse frequency and amplitude of GnRH. That leads to more FSH and LH, which leads to more follicular growth and spermatogenesis, and we start building up toward our E2 threshold. Once we get to that E2 threshold, then we're going to have that GnRH surge, and we essentially begun our cyclicity. How does kisspeptin fit into this picture? So I think one way to really kind of help you understand this is if we draw some neurons. So this is going to be a kisspeptin neuron. Okay, we'll draw red will be kisspeptin. Okay, so I'll just kind of, red is kisspeptin. And then we're going to draw another neuron, and this one's going to be our GnRH neuron. Okay, so our yellow one is our GnRH neuron. And as we look at this, I want you to focus on this P4. So estradiol and progesterone both can have negative feedback through steroid receptors that are found on the kisspeptin neuron. So you could draw some little R's here. These are going to be receptors that are on the actual neuron. And as progesterone attaches itself to this receptor in this kisspeptin neuron, okay, what that's going to do is it's going to travel down. It's going to prevent GnRH from releasing, or GnRH neuron, excuse me, from releasing GnRH into the portal system. Okay, so in this particular case, we have P4 that's going to bind with these receptors. Okay, here's our P4. P4 is going to bind to those receptors, and it's essentially going to prevent GnRH neuron from releasing GnRH. Okay, so in this particular example, we're not going to get any GnRH. Now, if we look down here, we have a similar scenario, but we're going to have receptors that are positive feedback receptors. So in this case, we might have E2 here that's binding to these receptors that is then going to affect, okay, so it's going to travel down, it's going to affect our GnRH neuron, where now that GnRH neuron is going to release GnRH into the blood portal system. So this is going to be representative of GnRH being released into the portal system so it can then go affect the anterior pituitary. Okay, so one way to look at this, so in the negative, we're preventing GnRH from being released, and in the positive feedback system, we have E2 attaching to the receptors on the kisspeptin neuron, and it's going to cause a release of GnRH into the portal system and affect the anterior pituitary. So one of the things is I do not expect you to know every pubertal age, range, mature weight for every species. What I would like you to do, though, is pick a particular, if you're a beef person, know everything there is to know about heifers and cows. If you're an equine person, know everything there is to know about fillies and mares, swine and so forth, gilt to sow. Know the age of puberty, be familiar with the range in months, and then really think about what's the mature body weight that we would expect at puberty. And in cattle, that's one I always like to use because at breeding, when we're breeding beef heifers, we like them to be between 55 and 65% of their mature body weight at breeding. And then by the time they calve, they should be around 85%. Okay? And one last key point is the female has to be near her normal age of puberty before the Surge Center really responds to increasing E2. So we know there's these other factors that we're going to talk about in subsequent videos, but just realize we do know there's typically a normal age range where regardless of what we do, they're going to fall into that puberty range. Now, we can select, we can feed, we can do some things with the environment that would help improve that age of puberty, but again, it's typically going to be around a pretty predictable age.